Okay. Um, Good afternoon, everybody. It's 4 o'clock on Wednesday. Today's topic is going to be the other kind of loops in Python, while loops. We've been talking about for. While is actually more general, and we're going to go over a few things about them and why they're different and why they're more powerful and also more dangerous. Before we do, I want to go over a couple of administrative points. First, as I promised, I have put out a sample exam. It should be on Blackboard, and you should be getting a notice that it's available on Blackboard. This is almost the first exam I gave in this class last semester, spring of 2020. It's 10 true false multiple choice questions. It's I believe 5 short answer questions. It's a debugging question and 2 write Python code questions. You can take it anytime between now and Tuesday. You don't have to take it. If you want to just ignore it, that's fine. There's no issue there at all. Feel free. But it's meant to give you practice and, as I've been saying, some awareness of what you're going to face next Wednesday. Once you start the test on Blackboard, you'll have 90 minutes, both with the sample and the actual in-class test next Wednesday. It's worth 75 points, so it'll tell you how much each question's worth. Don't worry yourself about why it's not equal to 100. The answer is because it's only worth 75. Just like next Wednesday's test, obviously the sample exam is open book. You can, work it any way you want to. You can have access to any resources you want. And in terms of getting it done, I will not see the results of your sample exam. I will not grade it. You will be told, because of the way Blackboard works, you'll be told whether the multiple choice true, false, or right or wrong. The rest you won't be told explicitly, this is right, this is wrong, what have you. But if you recall, next Monday, the 5th of October, is a review for the test. So one of the things I'll be doing Monday is going over the sample exam, answering any questions or whatever you might have. During the actual exam next Wednesday, the exam is on Blackboard. I will be available through WebEx. I think WebEx, maybe Discord, but I think WebEx. If you have any questions, if any of the questions are confusing, if things are not clear, if you're not sure what I want, what have you, I will be available during the test. Obviously not during the sample exam. If you have any questions about the sample exam, feel free to ask them. And send me an email, contact me on Discord, or you can ask them in class next Monday. This is really, as I said, just there for you to get comfortable, with the online education, and we're not sitting down taking tests on pieces of paper in class. I want you to get comfortable with what the situation is going to be next Wednesday. I want you to be familiar with it, so you should be good to go. There are no labs next week. So next week, there's no labs and there's no homework assignment other than the one that's due next Monday night. We leave the week for the exam and the exam only. So don't worry about lab next week. Don't worry about any homework once you finish homework 4. Next week's focused on the exam. The other thing administratively, before we get into while loops, that I want to talk about is homework 4, because it's got some new things that we really haven't covered in class, and I want to go through them. So homework 4 has been put out. It's due next Monday night at midnight. Majors, it's due at midnight Friday. We get the time. You get the weekend to work on it, and you have next Monday during lecture to ask questions if you haven't asked before that. The big thing about homework 4 that's different from anything you've seen before is that you have to import code from other places. Okay, so if you look at homework, if you look at part 1 of homework 4, It talks about importing and how you do things. Now, this is really a topic we get into later in the semester, but it's needed for homework 4. So I want to go through that just a little bit in PyCharm, work some examples, and show you what we're facing here. Now, in Python, as we've said, the advantage is one of the reasons we teach this language. The advantage to it is there is a ton of freely available code, open source, out there available for you to use. Once you get into it, you'll be writing, if you use this to solve homeworks in college or do things professionally, you'll be writing some of your own code, but a lot of your solutions will be importing code from other people and using it. Okay. And so homework 4 does get you into that. We've told you before, and I know I haven't gone over it in lecture, but the TAs have in lab, you've been using this really funny looking statement that says if underscore underscore name underscore underscore equals underscore underscore main underscore underscore. And then you write code after that. Here's what's happening. In Python, like a lot of other languages, you have two parts of a program. You have the main program. The main program is the core of what you're writing and executing right here. In addition, you have what's called functions. Functions come up in a couple of weeks. Functions are routines that are already written and are reused all the time. It may be something you've written yourself, and we'll get into cases where you're going to write a function and then you're going to import it into another program you write. But it may be something else. Yeah, this is not good. Sorry. Okay, I've lost access to UMBC. And let's see. Do I still have access to GitHub? Yep. Okay, here we go. Sorry about that. It appeared I lost my UMBC email in the middle of lecture, which should not be an issue. Okay. Any rate, it's functions that people have written that you can use in your program. In this case, sys, it consists of a bunch of functions that have already been written and that you can use, and you bring them into your Python program by saying import sys. Now, that means anything that exists in the sys routine that's out there in Python, you can use. These are included, the things we're talking about now are included with a standard Python load. So as long as you've got Python 3.8 on your computer and running, you should not have a problem with this. If you have some other issue with this, let me know running these. There's another library out there called random. Random is a whole bunch of functions that let you generate random numbers, that let you use random numbers. Now, these are not, strictly speaking, if you're a mathematician, these are not purely random numbers. They're what we call pseudo-random numbers. But for the coding we're doing, it's a good approximation of a random number. We don't need to import all of the library of functions in random. We're only going to import two different things, choice and seed. So what these two statements do in homework 4 are they let you import the entire library of called sys that lets you interact with your system, and they let you import specifically the choice function and the seed function that are in the random library, and now you can use them in your program in homework 4. So that's what that's saying. Import sys, and from random import choice and seed says somebody out there has written this code already, so you don't have to rewrite it yourself. And we want you to use it. To be able to use it, you have to bring it into your program. You bring it into your program using the import statement. So in homework 4, part 1, these are the things you have to do. Choice literally makes a random choice of elements from a list. So you can see from the statement above, use choice of rock, paper, scissors. We've defined a list of 3 strings. One string is rock, one string is paper, one string is scissors. Those three things together are in a list. Choice from random of those will, each time you execute the program, randomly choose one of these three things. Okay. And so we could have you write your own mathematical code to randomly choose one of those three, but why bother? It's already out there. You get to import it. So that's what we're doing here. Sys down here, don't worry about argv. We'll talk about it. For now, this code just works. And they give you some examples. Basically, all that's going on is in part one of homework 4 is you're importing this code that lets you randomly pick, it lets your program randomly pick rock, paper, or scissors. The user enters something and you're told whether you win or not. Okay. Homework 4 part 2 is a variation on the Caesar cipher called the Caesar salad cipher. Don't get worried about the wording. It can be confusing, but it's actually straightforward. All this does is let you go through and randomly encrypt things the user types into some other word. If you wonder how, we talked about homework 3 lexicographically. We talked about strings that ABC, it helps if I type the right thing, is less than the string DEF. Or more simply, lowercase a is less than lowercase d. That's also true. Here's why this works. Back in the old days, back when I was learning to program, computers stored letters in what was called ASCII, American Standard for Computer Information Interchange, ASCII, ASCII. Now computers use generally UTF-8. If it's not UTF-8, it's UTF-16. But it turns out that those have the same moral equivalent. How do you store A in a computer? You store it, I'll put this in the comments so I don't mess myself up, as 1, 0, 0, 0, 0, 0, 0, 1. We talked about how everything in a computer is zeros and ones, but we use higher level languages to store them. This is how the capital A is stored in a computer. This is how the small letter a is stored in a computer. Okay? And if you add these up in base 2, this has the value in base 10 of 65, and this has the value in base 10 of 97. No, this is not on the test. But this is what the function ordinal does. Ordinal just takes this character, capital A, and says it's 65. Ordinal takes the character, little a, and says it's 97. And the way it works is by converting these bits, converting the string of ones and zeros into a decimal number. So that's what's going on here. Ord of capital A is 65. So capital A is less than little a, because 65 is less than 97. In other words, capital A comes before little a in a dictionary because its value is less. So what's going on here in homework 4 part 2 is you're using that ORD function to get a decimal value. And what Python is doing is it's converting that string of bits, that string of ones and zeros, into a decimal number. And that's how it's doing the math to convert things, to run this encryption. When you import the code you need, the library you need, ORD will work the way it's defined. It will give you the number. And then all you're doing in part 2 of homework 4 is using that to convert a capital H into something else, to convert a capital R into something else. So it's fairly straightforward. Importing language using loops to do things. Okay. Part 3 is straightforward. You're drawing old-fashioned, really ugly ASCII graphics. You're drawing circles with lines of asterisks. Again, when I was just starting out and we had line printers, you would do this to show that you knew how to control a line printer. It's ugly, but we make you do it so that we can appreciate when we get to project 3 and you're using the latest, greatest graphics libraries out there, producing fantastic pictures. This is how it used to be, and this is where you are now. I mentioned UTF-8 and UTF-16 is how you store characters in computers in the computer today. These are what the codes are. This is how you store fancy things that aren't just letters. That's the 4 suits in a deck of cards: spades, hearts, clubs, and diamonds. These are the UTF-16 characters for them. And then a number guesser, again, you need sys. Rand int is just another function that's in this random library you're importing. It just randomly chooses an integer. You tell it, I want a random number between 0 and 100, and it gives you one. Mathematically, if you're a math major, it's pseudo-random. It's not truly random, but for our sake, it's random. So I wanted to go over that, make sure you've got that. You have till Monday night to do it. Should not take you too much. Really, when I sat down with this and went through it, a lot of the instructions were more daunting than the actual assignment is, just because we haven't imported code. We haven't done anything like that. Where is this coming from? This is new. So that's why I wanted to spend a minute or two going through this, making sure everybody understands it. So if you have any questions about homework 4, feel free to ask me. You can ask me in lecture if you got them already, or ping me, anytime afterward. I'm here. I'm available. I might be not available at the instant, but I'm available. Pretty much anytime I can help you understand, figure that out. And of course, you can always go to Discord and office hours and get the TAs to help you. That's not a problem. Homework 4 is really not that hard, but I understand the instructions can be daunting because it's a fairly new skill that we haven't covered yet. We're jumping ahead. Okay, fine. With that out of the way, let's get to the actual topic of today's class, which is while loops. Now, we've talked about for loops and the 2 different for each and for I. While loops, I hinted a couple of minutes ago, while loops are more powerful than for loops. While loops can solve problems for loops can't. There actually was a question on the exam last semester. It's on the sample exam that says true or false. Everything that can be written as a for loop can also be written as a while loop, but not everything written as a while loop can work as a for loop. The answer to that is true. You can do things with while loops that you cannot do with for loops. They're more powerful in general, and I'll cover some examples of them. We will cover 2 specific issues that come up a lot with while loops today: sentinel loops, which is where you're looking for a specific value, and Boolean flags. So let's get on to while loops in general. Again, while loops are more general. You can solve things with a while loop that a for loop cannot be used to solve for. When you know how many times you want to do something, you could use a for loop. It's simpler, it's easier, it's cleaner. You know the specific number of times to do something. You know the length of the string. You know the length of a list, whatever. With a while loop, we probably don't know how many times we're going to do something. If we're asking a user for input, and we'll cover this in the examples today, we are going to go until the user is tired. We're going to say, we're going to keep doing this until you hit Q or quit to enter. Okay, we don't know how many times that is. That might be once, that might be 0. That might be once, that might be a trillion, depending on how enthusiastic the user is. So with a while loop, we may not know how long this is going to run. It's going to run until we're done. That's the big thing, as I said, that if you don't know how many times something is going to run, a for loop is just not going to work. You need a while. Now, the syntax, very similar, but not quite the same as a for loop. You have while some Boolean condition is true, then you have some code executed, and remember indentation. The body of your while loop, the code to be executed under the while, has to be indented. Okay? It has to be indented under the while loop for it to be considered part of the loop and executed. Okay. Now, with a for loop, and we'll give some examples of what this next sentence means. With a for loop, Python automatically sets a value for your variable. A while loop, there is no automatic set. You must manually set the value of your Boolean. So let's look at this example. Let's go to, let me copy it, and we'll go to PyCharm, and I'll fix my smart quotes. I'm going to comment that out just because if I leave that in, as you've seen in your own programming, I have to indent everything under it. Okay. Fix that quote. Fix that quote. Fix that quote. Fix that. Fix that. And what's my problem right there? I have an extra quote now. That's my problem right there. Okay. Now, here is a while loop. This is going to run until the user, it's actually going to run until the user hits an age that's above 18, that's 18 or older. So let's execute this. Enter your age in years. 16. All right, what did I do? I did not cast it to an integer. Let's try this again. Yay, live demos. Here we go. 16. Okay, what happened was age is 0, right? Age is less than 18. That's true. Let's execute the while loop. Let's execute the while loop. I entered my age as 16. If you're 18, I printed out this message. And now age is 16. I go back to the top of while loop. Is age less than 18? Yes, it is. So now I'm at this statement again. I have to execute this again. Age equals input, enter your age in years. 9. Print the message. Go back up here. Is age less than 18? Yes, it is. This is a case where we don't know how long it's going to run. It's going to run till I, as the user, am tired. Well, I've just decided I'm tired. How old am I? 35. Not really, but we'll say for it. Now, I still printed this message that says if you're 18 or older, you should vote, because that's the next statement in the loop. Then I went back up here. Now, age is less than 18. Age is 35. Is 35 less than 18? No. Once this Boolean condition becomes false, I drop out of the loop. What do I do when I drop out of my while loop? I execute the next command that is not indented. Remember, Python indentation, the things that are indented under while, these are the things that get executed in the while loop. The things that are not indented, that's where we go when the loop is done. So in this case, I initialized age to 0, and I said, well, age is less than 18, age was input, print, et cetera, et cetera. This is the loop, these two statements. When the loop ended, I came down to this print statement, and that's the end of our story. So it works in the same sense like a for loop in terms of executing while the Boolean condition is true, then dropping out to the next thing that's unindented. You have to watch your indentation. One comment I made is I have to initialize the variable. Here I'm missing a right parent. That'll solve that problem. Okay. Here, age is not set. Okay. Actually, this will not illustrate what I want to. Let me change this so that I don't sabotage my own demo. Here we go. Age has a value. Since I'm running in the same Python console, age actually has a value left over from slop. It's garbage that's going to wind up impacting me. So I changed to a different variable. So the old thing, I could have either done that or killed my Python console and started over, and this was easier. The bottom line, the point I'm trying to illustrate right here is that this variable has no value. Now, with a for loop, that value would have been automatically set, right? With a for loop, this indicator variable in my for is automatically set by Python by the first value in range, by the first value in the list in a for each loop, by whatever mechanism. I do not, in a for loop, have to explicitly say this variable gets a value. In a while loop, I must. What's going to happen is that this is going to fail. And the reason it's going to fail is that the variable page has no value. Now, the error message tells me it's not defined. Defined means it has no existing value. I did not set it to a value. Therefore, when I tried to execute it, Python says there's nothing in the symbol table. There's no location in memory. I don't know what this is. So you must, in a while loop, set this. Now, I can explicitly set this, or another technique, and here I'm going to kill my Python console and start over and go back to this one. And I'm going to copy this line of code. Okay. And then after that, okay, let's fix that. Here we go. This, I'm setting the value. What I'm trying to illustrate is up here, I set the value of age. Before I called this, I set this value by explicitly setting it to 0. Here, I'm setting the value by getting it directly from the user. When I execute this code as a user, what did I do now? Still missing that right pair. Apologies. Here we go. This works correctly. In this case, I have executed the program. It looks as the user's the same. Just enter your age in years. 26. That's the end of our story. Okay, two things I want to illustrate about that. Let's get back to this slide. Now, I said, what happens if we left out that initial age equals 0 statement? That was the case I did where I changed age to page. The answer is the loop fails because age has no value. How many times is this loop going to be executed? We don't know until the user cooperates or gets tired or whatever. That's how many times it's going to run. Now, What I just did with the other code, I want to put in a slide. And I'm going to put this code here. And I'm going to fix my integer of it. Here we go. That'll fix that problem. And this has to be an int as well. So on the previous slide right here, I set the value of age. I set this variable by explicitly assigning it to 0. Here, I set it by asking the user. This is referred to as a priming read. A priming read says I read the value of the variable from somewhere and that set it up. Priming refers to getting an initial value before executing the loop. So in this case, I made a priming read to get a value, whereas on the previous example, I explicitly just set it to a number and didn't get the value from the user. The key is, and we're going to see more examples of this, this is a loop that in this case, if the user enters, say, 35, the loop never executes. Okay, the first time through the loop, while age is less than 18 and the user entered 35, this Boolean condition is false immediately, and this code in the loop will never execute. Okay, this will never execute. So that's an example of again, how while loops are different than for. Now, it may be that that's an error. You didn't want it to never execute. You just have a logic flaw in your code. You don't have the right Boolean condition, whatever. It may be that that's the behavior you want. This is an error checking routine. We're only going to print it out sometimes. We don't need to print it out other times. So that's what we want. And yes, a while loop will work perfectly. You'll have while loops that you will not ever execute. So point on this slide and the illustration what we're doing here with this loop is instead of explicitly assigning a value as 0, I get my initial value from the user. I still have to have that initial value. No initial value, this thing is not going to work. I have to have an initial value. But that getting the initial value from the user is called the priming read. Okay. But when I do this with a priming read, the while loop may or may not ever be executed. Okay. Let's talk about another example. Now, in this case, I want to calculate a number factorial. Okay. There are so many different ways to do factorial. I could do factorial with a for loop. I could do factorial without loops at all. It's ugly, but I could do it. But factorial with a for loop, number equals int, input, what number, calculate factorial for I in range 1 to number plus 1. And I need to do one more thing. Product equals 1. I got to start with 1. Product times equals I. Print product. Okay. All righty. That's a 1. That's supposed to, yeah, no, that's a 1. That's, sorry, that's correct. Let's see. All righty. What number should I calculate 5 factorial for? 5. 5 factorial is 120. I happen to know that. And you see, I've implemented this with a for loop. Points. I did not have to initialize my indicator, my increment variable here in the for loop because Python did it with 1. Reminder, I had to start this. I had to give this an initial value of 1 because if I had just said that this is range of number plus 1, remember that if you don't give an initial value, it starts at 0 and it gives you the wrong answer because you get a 0 in there. Okay, so by doing this,
no,
I had to tell the range from 1, so don't start at 0. Okay. Now that's a for loop. Let's do the same thing with a while loop. I still have to say product equals 1. Now, in this case, I'm going to say number. Let me just copy the statement. I still have the statement that gets my number from the user. And I have to convert it to integer. And that does not need to be indented. And now I'm going to say index equals 1 while index is less than or equal to number product plus equals index. Print product. Let's make sure I got that one right. Okay, let's calculate 5 factorial again. It should give me 120. Uh-oh, this is an issue. What happened? I never incremented index. Index is 1. Product plus equals index. Product equals product times 1. Is index still less than 5? Yes, it's still 1. Here is a case where this is never going to increment. Index never increments. And so this is what's called an infinite loop. Okay. To solve the infinite loop, I need to increment index. Okay, so we'll try this again. Kill that, get a new console. Let's calculate 5 factorial again. Obviously have an error there. It's not supposed to be 16. What did I do? Let's fix this. The answer is product times equal index, not plus. I summed 1 plus 2. I summed the numbers. I didn't multiply them. There we go. Now we're down to 120. So what we've done here is shown how to implement factorial as a while loop and how to implement factorial as a for loop. Now, in this case, the comment I made earlier, anytime we're implementing a factorial or something, we know how many times we have to multiply. We know how many factors there are in the product of a factorial. We know how many times the loop's going to execute. So factorial really is easier to do as a for loop, but we can do it with a while loop. And I unintentionally, I could claim I did that on purpose, but I didn't. I unintentionally made a good point about while loops, which is they can be infinite. Okay. So this is a case of 10 factorial. The example I gave you is uh, getting the value from the user. Straightforward, works the same thing. Now, here are some common programming errors with while loops that you generally do not have with a for loop. These are things that don't occur with a for loop. Because while loops are more general, they're a little more complex. You have to be careful. I've given you an example where a loop would be never executed. Okay. Here's a case where I've written code. It's simple to the thing where I typed in my age the first time with a priming read. My age is 35. Okay. Num equals 1, while num mod 2 is equal to 0. If this is an even number, print the num, increment the number by 2. And I want to print out all the even numbers between 2 and 100. But the problem is I started with num being an odd number. So just like in the case where the user entered 35 as his age with the priming read, here's a case where I've got an initial value explicitly set in such a way that the while loop will never be executed. It's perfectly acceptable to write a loop that's never executed. That's intentional. We're writing something to do an error code. We're writing something for specific users that doesn't get executed for everybody. We're handling special cases. It's perfectly acceptable to write a loop that doesn't get executed in some cases. But be sure that's what you really want. You have to make sure that this is what you really want. Now, is it possible to write a for loop that's never executed? Yes. You can say for a variable in an empty list. If you do for each in an empty list, that's a loop that's never executed. You can do it in a for loop, but it's a lot harder. This is a lot easier to have happen with a while loop. And so you have to be careful that if you're writing a loop, make sure it's executed, or if it's something that's never executed, make sure that's what you want. Okay. Common program. Here's another case of a loop that never executes with an example here. If I enter a value, the loop's never going to execute. But this is a case where I wanted to do it on purpose. What happens here is if the user inputs dodgy data, the user inputs something that is not a negative, not a legal value, something I consider reasonable, I'm going to go into the loop and I'm going to continue looping until the user is, sane enough to give me a real value. Pardon me. If the user inputs a sane value the first time, I never execute this code, this loop. That's fine. I'm happy. Okay, that's a designed loop that never executes if the user is sane and we get there. The other common error is something I just showed you unintentionally. I'd like to claim intentionally, but I didn't. An infinite loop. An infinite loop is literally one that would never stop executing. Now, as a practical matter, almost all computers have some kind of external limitation or factor that will stop. If you try to execute an infinite loop on GL, almost every time the Python interpreter will detect it and will refuse to run your program. It will stop. Because literally, if a program had an infinite loop and there was nothing external that stopped it, your program would run forever and you'd be sitting there tying up resources and wasting your computer and all of the memory and CPU power and everything else. And so there are external factors, a control C, a control Z, depending on what computer, GL's interpreter detecting it, what have you. It takes something external to your program to stop your program. Okay. There are a couple of cases, there are a couple of common things that cause infinite loop. Now, I will say this knowing it's not quite right, but for this course, it is right. You will never write code that intentionally has an infinite loop. You will never write code that intentionally has an infinite loop. It's just not something you do on purpose. When I say that's a lie, if you are writing a server, if you get to the point where you're writing all the code for your own web server, you might do that, but that's not something we do in 201. In 201, you will never intentionally write an infinite loop. If you do that, it is an error. Now, how can you do that? The note on the bottom, we'll talk about how to do that in a couple of cases. You can, it is mathematically possible to write a for loop that is infinite, but you have to really, really try. You have to really, really work hard to make an infinite loop in a for loop because you can't make the stopping condition infinite. If you say for I in range something, Python won't let you enter for I in range infinite. The only way you can get an infinite loop in Python in a for loop is to have a for I and deliberately reset the value of I every time so that it would never actually be incremented. Okay. Like I said, you really got to work hard. You got to want to make that for loop infinite just to prove that it can be done. Won't say it can't. She can. But we don't really worry about infinite loops. This is why we didn't cover this when we talked about for loops. While loops, it happens all the time. One of the reasons, just like I showed you in the example, you never change a variable. I didn't change I didn't change the index in my while loop. I never changed it. And if you don't change it, the Boolean condition will never change. It will always be true. The Boolean condition is always true. That's an infinite loop. Another case, and I'll give you an example in a minute, is you write your loop, you're going to stop when a variable takes on a certain value, but it never takes on that value. Okay, and we'll give an example of that in a sec. So here are some simple examples of infinite loops. Okay. Here's a case where I don't change the value in my loop. Okay. These I'd already fixed the blasted smart quotes. Okay. I start by setting values. I have to set name and grade to some initial value. So I just decided to set them to empty strings. They're strings. They're empty strings because of the way I set it up. And I'm going to ask the user for the grade, and of course, the university president, Freeman Hrabowski, Dr. Hrabowski. We're not going to worry about his grade. So as long as the user's name is not Hrabowski, I'm going to keep asking for grade. Okay. So I say, input, what is your grade? When we're done, when we're all done, this is outside the loop. I'm going to print you passed. Here's the problem. What's your grade? A. What's your grade? B. C. Here is a case where my Boolean condition is while name is not equal to Hrabowski. Well, this is a string literal. This is a constant. This is something that never changes. This is my variable, but I never change the value of name in the loop. I never change this value. So because I never change this value, this is a case where I'm going to have an infinite loop. I just don't ever change it. So let's kill that. Start over. That's one example. So that's the second time you've seen that. Here's a case where I've got here's a case where I've got code. I start with 50 cookies left, and as long as I have cookies left, I'm going to eat a cookie. Eat a cookie does something I don't know. I don't care. Okay. But then instead of decrementing the number of cookies left, I increment it. So the number of cookies starts out as 50, then it's 51, then it's 52, then it's 53. And so I can see that cookies left is always going to be greater than 0. So here's a case where I do actually change the name of the variable, but I change it in the wrong way. This condition is never going to be false. The third example, and the more interesting one, is this one where I thought about the program and didn't quite get there. Okay. I want to print out all of the odd numbers less than 100, less than or equal to 100. And I want to start, of course, with 1. So how do I get an odd number? Well, if I start with 1, I just add 2. Okay. But here's the problem. Actually, this is the fixed thing. Oh, this is not equal to, yeah. I'm going to stop when I hit 100. So as long as num is not equal to 100, I'm going to keep going. The problem is that when I do this, num is never going to equal to 100. So we'll run the code, and we can see that num is 135. Holy cow, I'm up to 350,000. Okay. The reason it's okay, the reason it's doing that and continuing to run is num, this is set to stop when num is equal to 100 because I'm doing not equal to. I set it to stop when num equals 100 because I've got odd numbers 1, 3, 5, 7, 9. 100 is not an odd number. Num is never going to take on the value of 100. So this is the other case I was talking about on the previous slide. A common cause of infinite loops is you never change a variable, and I probably should add, or you change it the wrong way. The second example I gave you with cookies left, I'm changing the variable, but I'm changing it the wrong way. It's never going to fail. This one is a case where I wrote my code. I plan to stop when a variable hits 100. When my variable takes on the value 100, I'm going to stop. But odd numbers are never going to include 100. So the bottom line on that one is that I didn't think about it. It's a semantic error. It's not an infinite loop is not a syntax error. The code will actually run. It's a semantic error. It doesn't do what I want, and it doesn't do what I want because I didn't think about it. In the code I just showed, if I changed not equal over here, if I changed not equal to less than or equal, or just less than, that would be fine. So it's a semantic error. Logically, I didn't get this figured out right. I presume that num would take on this value, and it's never going to. So those are the cases that we have infinite loops. So the point of that part of the lecture is when you're writing while loops, they're more powerful. They can solve problems that for loops can't solve, but they have error conditions that for loops don't have. Again, you can consider for our purposes that for loops don't have infinite loops because it only works if you try. Okay. Perfect. So the next part of the lecture on while loops is there's a couple of special loops. Sentinel loops. A sentinel is something that you're looking out for. A sentinel is a person who's looking out, or it's the person, or it's something you're looking out for. So in this case, a sentinel loop is a loop that runs until a specific value is encountered. That denotes the end of the data set. We call that the sentinel. The sentinel is a value that denotes the end of a data set. Simple example, let the user input data. The user inputs Q to indicate it's time to quit. Q in this case is the sentinel value. So here's an example. And let's make sure I fixed all those blasted quotes. Let's go over to pie chart. No, I gotta fix the quotes. Hang on just a second. All right. let's see, where else have I got to fix it? There we go. That should work. Let's make sure I've got everything. This has to be indented. This has to be indented. This has to be indented. This has to be indented, and this has to be indented. Here we go. All righty. So this is a very simplistic way of calculating what day of the year you were born, given your month and date of birth. Okay. This is not exactly correct because I'm just assuming 30 days a month. If I wanted to, I could create a list of the number of actual days in a month, 31, 28 or 29, 31, 30, and so on. But for simplicity, all I'm going to do is say I'm going to read in your month and date of birth. And once I have your month and date of birth, I'm going to split it on the slash. So I'm asking you to type in your birth date, don't care about year, month and date, as month number slash day number. I'm going to convert that into that string into a list using split on the slash. I had you enter it with a slash, so I'm going to split on the slash. I could have you enter the two numbers separated by a space and do a split on the white space. If I could, I wanted to illustrate you could do a split on the slash. Now, remember that was a string. Input is a string. Splitting the string gives me a list of two strings. Now I need to convert those strings to integers to do math. That's what this does. I just wrote a two-step for loop to convert the two strings, month and date, into numbers, month and date. And then I did my silly formula that said I'm going to multiply the month by 30 and add by 30 and add the month and date. And this actually gives you the wrong answer for a reason. I realized after I wrote it, it gives you the wrong answer, but we'll talk about that. So, at any rate, I have it down here, and then I ask for the next user. Enter your month and date of birth as month, date, date. Enter Q to quit. Well, let's say I was born on September 7th. I picked that date because it was Labor Day this year, so why not? Well, you were born on the 277th day of the year. Okay, that turns out to be wrong. What's the month and date of your birth? As let's say you were born on January 1st. Here is an example of why this is wrong. If you were born January 1st, you were born on the 31st day of the year. That's clearly wrong. Well, the program says enter Q to quit. So I'll enter Q and I will quit. Done. Okay. It should be noted that I am only going to quit on a capital Q. So if the user entered a small q, the program would crash. So we got to think about this. You got to think about writing what the sentinel is. Here, we told the user it's only a capital Q. If the user enters a small q, well, that's why we call users losers, because they're not smart enough to do what we want, RR. And I could actually change this to say while equals Q, capital Q or small q. Now, here's my bug. I'm actually multiplying by 1 month too far. I need to subtract 1 from the month entered. Why? Because January is the first month of the year. I don't want January to add 30 days to my birth date. What did I lose? Okay. So now, if I enter 1/1, yeah, now what did I do wrong? 30 times. Ah, operator precedence. That's what I did wrong. I do the multiplication first. I should not do the multiplication first. I need a parenthesis here, and I need a parenthesis here. And I'll fix it here. And a parenthesis here. And we're going to the bottom. Okay. Let me just fix this. What did I do? Put the parenthesis there, put the parenthesis there. Now we're down to okay. There we go. Now, 1/1. First day of the year. How about that? Labor Day. The 247th day of the year, using this silly math I did here. That's an illustration. Okay, so what was I trying to demonstrate here? A sentinel. A sentinel loop example is I'm going to keep going until the user gets tired and types Q to quit. Now, again, because of the way I wrote the code, it has to be capital Q. We'll have other examples where you type lowercase q or higher uppercase Q. You actually may have to type out the string quit, what have you. But now think about other programs you've run. Think about software applications you've used when you realize, maybe it's not being logical. It's not looking for values you would type. You type in something you think says quit and it doesn't quit for you. That's because the programmer who wrote the code maybe didn't get these conditions fully out there. And that's fine. It's good programming practice. This is an example of a sentinel loop. A sentinel loop, what is it? It runs until a specific value is encountered, and we call that value the sentinel. And the sentinel indicates the end of a data set. Now, for now, all we're doing is all the input comes from the user. Later in the semester, we'll be reading files. We'll look for the sentinel that marks the end of the files. That's fine. It's the value that denotes the end of a data set. That's a sentinel. And again, the simple example, tell the user to type Q to quit. The other thing we want to learn about while loops is a Boolean flag. A Boolean flag is just a specific example of a while loop where our while statement, instead of being some expression, is a simple Boolean variable. Here, I've got some examples. All right. Trying to make this bigger. Here we go. Hopefully this is a little better. This is the loop we've been doing. Tell me something cool, then enter quit, the sentinel value quit to end the program. I do an input to get the message, and while message is not equal to quit, print the message, input prompt again. Okay. Here, I just combine two strings together. That's fine. So all those two things are doing is combining two strings together. Here's my priming read. I get an initial value. Message has to be initialized before I can execute the program. My priming read gets an initial value. Here, Sentinel, I'm looking for the value quit, print, do something, get another value increment. So it's not an infinite loop. It's going to run until the user says quit. This is a Boolean condition, but our terminology, this is not a Boolean flag. It's not a Boolean flag because it's a whole expression. It's not a simple Boolean variable. When there is a Boolean flag, this is exactly the same thing, same logic, but the actual syntax is different. Here, my entire condition is a single Boolean variable. Active is a Boolean variable, which I initialize to true because of the way I've written the program. And I know this loop's going to be executed at least once. And then I do something in my code. This actually has exactly the same semantics as these. These two code blocks work identically in all cases. The issue is that here I have a simple Boolean variable, and this Boolean variable is called a Boolean flag. And why are Boolean flags important? Because some people like code where the condition is just controlled by a single variable. Okay. So while loops, that is a Boolean flag. So this is the last new material that's on next week's test. We've covered everything till now. Let's go back into make this smaller so I can get back to my slides. As far as today's material, we covered the things we had to know. While loops in general, they are more general than for loops. You can solve problems that you can't solve with for, but they are more complex and more dangerous. You can make errors with while loops that you really can't make with for, or that are really, really very hard to make with for. Okay, so more powerful tool, more danger to the tool user. That's okay. You become experts in computer science, you'll use the while loops. Infinite loops are problems. Loops that run 0 times that you didn't intend to run 0 times are problems. We can deal with it. Sentinel loops are specific examples of while loops where you are going until you get a certain value. Often that means input from the user. We're going to keep running until the user says quit. Keep running until I'm done. That's a sentinel loop. The sentinel is the value that we're looking for to quit. And a Boolean flag is just when we have a loop where the Boolean condition is a single Boolean value. All we have is one value. We don't have a while this is greater than that, or while this is not equal to that, or while this is less than that, or something else. We have a single Boolean value that's called a Boolean flag. And in some cases, it makes for a simpler loop. So for exam 1, that's what you need to know about while loops. We will cover some more details after exam 1, but that's in unit 2 of this course. As I've said, this is the end of the new material. The sample exam is out there. Take it whenever you want. We will go over it in class on Monday. In addition, I will talk about anything else you want on Monday. Monday is no new material. Monday is dedicated to review. The exam is Wednesday during the class time. You'll actually have 90 minutes, so you'll actually have until 5:30 next Wednesday to take the exam. If there's some issue and you cannot make class next Wednesday at 4 o'clock, you have to let me know. I don't want to get you a 0 on this exam. You need to let me know that you won't be able to take it, because the way Blackboard's set up, once 5:30 on Wednesday comes, your access to the exam is over, and we can't make this happen. So if you cannot make next Wednesday, let me know as soon as you possibly can. As soon as you find out that you can't make it, let me know so we can make arrangements. Homework 4 is due next Monday night at midnight. We talked about it. Don't be daunted by importing code. It's straightforward. The homework itself, I think, is kind of on the easy side, which is intentional with the exam coming up. If you run into any of the majors, anybody taking the major section, their test is take home. They will have part of it on Blackboard, but their test is take home next week. So they'll all be worried about it. You'll just get it out of the way in 90 minutes. And frankly, I prefer that. That's why we're doing it this way. No lab next week. Talk to your TAs if they may. I don't know if they'll be available for office hours or not. They don't have to be, but they may. If you have questions, you can ask them about homework on Monday or whatever. As I said, I will be here regular time on Monday for lecture. Topic of the lecture is review for the exam. Exam on Wednesday. I will be online on WebEx live throughout the exam in case you have questions, in case you don't understand something. If taking the sample test on Blackboard, you don't understand something, if you can reach me at that time, I'll try to help. If not, we can talk about it in the review. And with that, I have been long-winded enough, and we are done for today. Have a good weekend. Good luck with the homework, and I will talk to you all on Monday. And again, I'm available between now and then if you have questions. So thank you all.